Hello guys, welcome back. More Christmas lights, more battery powered ones this time, so there shouldn't be anything going bang this time. Unless I drop something or so on. But anyway, what we got is Product Works made in China. Quality brand alkaline batteries recommended. Battery selection may affect performance. Yeah. And like any good American, we mix our batteries because why not? Because it's what we have on hand. Well, these are working just fine. However, same problem as the other battery operator when they do kind of chew through batteries. Now these lights here have been in storage and they have seemed to have gotten mud wasp dirt on them that I've been trying to clean off. I thought I had it all off, but apparently not. And something sticky there, some kind of tape or something. But you can see these ones, they alternate like that. They also have a off alternating and then a steady pattern. So I do want to current limit these. So first thing I'm going to do is take batteries out, of course, because even though it's not a lethal voltage or a voltage big enough to make anything go bang, it can still let out the magic smoke. So I'm going to pull this board up. This has this little driving circuit board on it. We have a power that comes in to the board. And we also have a powered common going out to the lights. And this is basically the same arrangement, kinda the same arrangement, minus the power supply that exists on this board that went bang yesterday. You've got a microprocessor driving two transistors that do the switching for the alternating switch. What I want to do here, since this thing needs the power to run this, I'm not going to limit the current there. I'm going to limit the current off of the common lead right here. That means I'm going to put a resistor in. I have two of them, and I'm not going to put a heavy resistor on. I don't have any more 68s, so I'm going to use a 56. I have two. I have a 1/4 watt and an 1/8 watt, and I'm thinking I could probably get away with the 1/8 watt. It'll be more than sufficient for this little application. So, and I'm really thinking about updating the wires and the soldering on this because it's kind of dodgy-ish, kind of dodgy looking, and it's also twisted. So what I'm going to do is push some of that wire out. I'm going to leave that in, and that will be the positive right there. And the other one is the negative. What I need my little drawer of wire is a red wire. So we'll get a piece of this red wire out of here. I have this. And I should also have a black one to match it if I can find it. Why is this tangled up in here? Wow. Okay. Off camera, you can't see the disaster that is the wire scrap drawer, and it's probably a good thing you can't because it's really bad. It is nothing but a rat's nest in a drawer. So I have a red and I have a black, and I'm going to do this way. The Chinese wire that's in here is not up to my liking anyway. Now these lights are about a year old or so. I can't really remember where I got them. I think I got them at Dollar Tree or something last year. For $1, not bad. Yes, LED lights, can't go wrong with that, right? So I'll get to work on this. So strip this, tin this, and we'll replace, and that'll strengthen those wires. They feel like they're about to pop off at any moment. Put this all aside. That I had to change soldering irons. My other iron died on me. It needs a new heating element. I'm not even going to do that. I'm just going to see about getting a new, an entirely new soldering station at some point. I do have regular plug-in pencils. And of course my isolated power supply will allow me to adjust the heat on these. If this one is too hot, I feel it up here. So I don't need a fancy soldering station, though I might invest in one. It's got a desoldering pump on it, just to make it easier. I don't have to plug in two separate machines, or has a heat gun or something. Okay, now, what do we want to start with? The positive. We're going to start with the positive. It's this one. I'll just remove this off. And I'll remove it from there. And I want to keep that wire on right there. And, well, actually, I want to take that wire off too. I'm going to have to join. We're going to output the resistor on that. But first, I want to tie in the resistor to this wire somehow if I can. I probably need to strip this more. And I'm simply going to wrap it just like I would be if I was connecting the wire to it. And then I'm going to solder it together like this. The soldering iron tip is kind of in sad shape. It's been kind of the beat around toolbox soldering pencil. Yeah, it's not the best, but it'll work for now. I probably could put another tip on that and it'll be just fine. Okay, now put on this, put this back on the terminal. Knock out all that lead-free solder the Chinese love to use. They got like the highest pollution in their country, yet they use lead-free solder. Being devil's advocate. So we're going to redo this. Cut that. So this would be a common lead, or positive, to the LEDs, or the anode, I believe, is what it would be, going to all the LEDs. The others will be the negatives that are switched. In other words, they're being pulled to ground. In other words, it's easier to make a transistor pull to ground than to pull high. It's much easier, less circuit. So it makes sense that they would do that. Okay, now we can take the negative off. That's the positive. This is the negative. This is just cheap wire that they have used here. It's kind of horrible. This tab's bent that way. Just solder. Come on. Oh, come on. Don't melt the wire. What in the hell are you on there? The tip of the iron's getting kind of funky. Trying to stay in frame, probably horribly off. Man, this thing is really bad. It's just oxidized really bad. It's been sitting. I should have got my sponge and stuff out, but you know, whatever. It looks like it could use a little more to kind of stabilize it. There. Yes, there's a fan running, so don't panic. Everything's ventilated. You just can't really hear it well. Okay, now this will go in here. If I pull the wiring back down, this will tuck under. Positive will come around here and kind of come up this way. And the negative will do the same thing. So I need to get this settled up and in here where it's not going to fall to pieces on me. And well, that's why it was bent that way a bit, because the switch. Transistor switches. Okay, come on. There's a stud there. These need to come up this. Okay, we go. There we go. Now, this one will tack onto that pad. Remember we said that was positive. Oh, and it falls off? Interesting. That's interesting. Come on, don't be a dick. Don't be a ding dong. It's these things have a mind of their own. They're moving around it on their own accord for some reason. Guess it could. Okay, that one's on. It's not on as good as I would like it, but it's on. And that one's on. It's a much more solid connection, and I know what's going where now. Now I can take time to tuck everything out of the way as best as I can. Make sure nothing's getting pinched. These two are being hard-headed. They don't need to go that way. Come on. Ugh. I don't want to break these two off. Cheapness is real. Okay, I think these, yeah, they gotta go up there like this. Okay, let's make sure that the lid's gonna go back on now. Perfect. Alright, let's put the batteries in. Put the 56 ohm in. Resistor is in the common. That way we're not shorting the power from the microprocessor that's going to need it. And they're still bright. They're not as bright, of course, as they would be normally. But they will last a little longer. You can definitely tell with this yellow one here. The blue is very bright. The red's pretty bright. The green is, the yellow, you can definitely see it. It's definitely gotten dimmer. So I'm going to fire them straight on. Now you can see that the blues, they're just running straight, you can see the blue has dimmed way down. So as the green. The reds are still pretty bright. You know, in comparison to that, the red and yellow are dimmer than the other two. But anyway, so yeah, that's that. Put it in the common. 56 ohms. Save the current. We will continue our Christmas light and other Christmas whatever extravaganza as I come across them.